All right, quick comment before we go on to the next video. I had a small error right here in the first video. This quantity right here, I said was negative 42. It's negative 40.5, okay? So it just slightly changes the answer. But what's really interesting, if you're looking at this derivative, is if you solve it with this method, this is your derivative right here. If you solve it with the other method, your derivative actually looks a lot nicer. It's a little bit more work because you have to use the product rule, but it simplifies to something nicer. And what's interesting is that these are the same exact equations, right? The relationship, right? X and Y have relationships, so there's different ways of expressing this derivative. Anyway, fun little fact. You could, depending on which way you solve it, you might get a different looking answer than the book, but when you plug things in, you should get the same exact equation. All right, so we're going to do the last video of the section, which is just more examples. Example 4. We'll do it in white. Example 4 says, suppose X and Y are differentiable functions of t. So what this might mean is maybe X and Y are positions. Imagine a particle that's moving on the XY plane, right? So, you know, it starts off over here and then it moves over here and then it moves over here. So X and Y are both changing over time. That's one interpretation of a problem like this, okay? And specifically what I want to know is I want you to find dy dt. So here we have to do things a little different. We're not going to ddx both sides. Yeah, it's called a parametric function. What we're going to do is take both derivatives of both sides with respect to t now. So now we'll have to use the chain rule on both things. Oh, there's supposed to be an equation here, by the way. Really losing it today. X squared plus 5y squared equals 36. This is the relationship between x and y, and they're both changing over time. We want to find the derivative with respect to t of both sides. So derivative of x squared is 2x. But now x is a function of t, so we have to multiply by the derivative of x, which is x prime. Or we can write it as dx dt. Plus the derivative of the second thing is going to be 10y. Y is also a function of t. We have to use the chain rule, y prime, or dy dx. Oh, or dy dt. Derivative of the right-hand side is a constant. Derivative of the constant, which is 0. So we want to find dy dt. So we're going to solve for this guy. So subtract over that first term. We're subtracting over the 2x dx dt. We're left with 10y dy dt equals negative 2x dx dt. And now we're almost done. Just divide both sides by 10y. We'll have dy dt equals negative 2x dx dt divided by 10y. This relates. How does the y coordinate of this particle change over time? And it depends on the x coordinate, it depends on the y coordinate, and it depends on how the x coordinate is changing over time. So part B is going to ask you to find something related. We'll do part B on the next page. Part B says find dy dt when x is equal to 4, y is equal to 2, and dx dt, right? It relies on 3 things. So find that dy dt, find the rate of change of y over time when we have all these values. So we just plug it in, okay? So this is going to equal this last thing, negative 2 times x, and x is 4, times dx dt. This is why it would have been easier on the other page. Dx dt, we said was 5. All divided by 10 times y. What is y? Y is 2. And then we just simplify this. Okay. I'm going to potentially make another mistake by doing this in my head, but the 2's are going to cancel. 5 is going to cancel, turning this into a 2. We're just with negative 4 over 2, which is negative 2. All right. So this says that under these specific conditions, this particle at this moment in time is moving down 2 units every second or minute. We don't even know the units of time. All right. That's one example. Let's do one more bonus example. Example 5. And then you can get ready and finish the homework assignment and do the quiz. So let's say, I'm going to write this one out. I usually like to write these out before starting the video, but I was a little preoccupied with fixing that other mistake. Let's say example 5. We can sell X 1,000 units at P dollars per unit, according to the formula that I'm going to write down in a second. Question is, how fast are sales changing when X is equal to 4, equals 6, and price is falling by 40 cents per week? All right, so again, just more chain rule stuff like we were doing in the previous section. Very, very similar. It almost looks exactly the same. Our demand function now, we don't have it solved for P. P plus 2x plus xp equals 38. So if we solved for P, this would be exactly like the previous section, okay? And actually we could solve for P. This is solvable for P. But we will use the chain rule plus implicit differentiation here. So again, just like in the previous section, how fast are sales changing? That wants to know, how is the rate of change of sales? Sales is X, right? Sell X 1,000 units, right? So what is the rate of change of sales over time? And again, it's going to be the chain rule. Price is falling. We can find rate of change of X with respect to price. Multiply that by how is price changing over time. We know price is falling by 40 cents a week. We know X has a relationship with P. All right. We can take the derivative of both sides with respect to P. That's how we're going to start. So the derivative of X with respect to P, we're going to take dp of both sides for this first guy, right? This first thing right here, we need to dp both sides. And remember that X is a function of P. So when we dp both sides, derivative of P with respect to P is 1. Derivative of 2x with respect to P is 2 times the derivative of X with respect to P. Actually, hold on. Let's do this separately. We'll plug it in later. We have to solve for dx dp before we can plug it in, right? All right. Plus, again, product rule. Derivative of the first thing is dx dp times the second thing. We're looking at the derivative of this right now. Second thing is just p. Plus the first thing, x, times the derivative of p with respect to p, which is 1, derivative of the right-hand side, 0. We need to solve for dx dp. So we can use that chain rule. All right, so we need to move some stuff over. We need to subtract a 1 over and an x over. We subtract over everything that doesn't have what we're looking for. And what are we left with? We're left with dx dp. 2 of them, we'll factor it. 2 of them from that first thing, and p of them from the second thing. On the right-hand side is negative 1 minus x. We're almost done. Dx dp is equal to negative 1 minus x over 2 plus p. So we're almost done. Right, now we can plug in. Now we can plug into this formula. Oh, that's not what I wanted to do. And now I can't undo it. So dx dt is going to be dx dp, which we just found, right? Negative 1 minus x over 2 plus p times dp dt, which is right here. How is price changing over time? It's falling by 40 cents a week. That's a negative rate of change of $0.4. And specifically now we want to know, how is this thing changing when x is 4, p is 6, and the other thing is the case as well. So just plug in x equals 4 and p equals 6 and you'll get your answer. When x is equal to 4, we get -1 minus 4, -5. P is 6, 2 plus 6 is 8. Still multiplying by 0.4. And we'll get that dx dt is this product, which is -5/8 times -0.4 is 0.25. What are the units? Well, it's always the units of the numerator divided by the units of the denominator. The units of the numerator are thousands of units. So we could say 0.25 thousand, or we could say 1/4,000, that's 250. 250 units per unit of time. Unit of time is weeks. And specifically, it's growing by 250 units every week. So again, if the price is increasing, or if the price is falling, and again, the price is falling here, the price is falling by 40 cents a week. If the price is falling, that means we can sell more. The fact that our answer is that we're selling more every week is a good thing. All right, kind of makes sense. And that's this video. Good luck. Let me know if you have any questions. Remember, you do get extra credit points every week if you ask or answer at least one question via Slack. Okay, so if you feel like you want a couple points and you're looking at the homework and say, well, I don't understand this, go ahead and ask a question via Slack. Double benefit. And you can also answer other people's questions as well. If you know all the answers and still want extra credit, there is a way. Good luck. Bye-bye.